We are going to start on page 8 of your Unit 10 packet. So if you need to pause the video to go ahead and find your Unit 10 packet and turn it to page 8, go ahead and do so. If not, go ahead and just keep watching. So yesterday we learned a bunch of different things, and I'm going to ask you to go ahead and utilize those 4 theorems at the end of the hour that we discovered. So with those 4 theorems, we have to change a couple things on your problems. So first off, I want you to note that this actually should have a right angle at M. So we need to know that this is perpendicular. So would you please add that to your diagram? That should have been given to you, and I forgot to give it to you. So now that we know that, we should be able to answer this. I want to just give you some hints, and then I'm going to have you pause the video and try it on your own, and then come back and see how you did. So looking at this guy, we have central angle BOC. So we have a central angle here. And if we can find that central angle, then we can find the arc BC, and we should also be able to find the arc BA. So we should be able to find all of that information once we can figure out what that angle is. So I'm going to ask you to think about what kind of triangle is OMC, and how can that help us find the central angle BOC. Go ahead and pause the tape or the video and go ahead and see if you can come up with all the answers for this, and then we'll go through it when you're done. So go ahead and hit pause, and then we'll see you in a minute. All right, now that you did that, we are going to go ahead and make sure that we have this down. So BOC, that angle would have to be a 45-degree angle, because this is a 45, 45, 90 special right triangle. Then for BC, since arc BC goes with central angle BOC, we know that this would also be a 45-degree, because every central angle matches its arc. Then we're supposed to find AB. Well, this would be a radius perpendicular to a chord. Therefore, we know this chord has been bisected, and this arc has also been bisected. So arc AB would also be 45 degrees. Now we're supposed to find AC. Well, 45 plus 45 is 90. And then AEC would have to be the difference between the 90 and 360, because AEC should add up with AC to be 270. All right, then we are supposed to figure out what MC is. Now, you were given that AC is 20. So if this whole chord is 20, and we know that it's being bisected, I know that MC has to be 10. Now, if this is a 45, 45, 90 triangle, I know that OM has to equal MC. So I know that that has to be congruent. So that is also 10. And OC, I know that the hypotenuse in a 45, 45, 90 triangle is the shortest side times the square root of 2. All right, let's go ahead and go on to the next problem. So again, we need to add something to this problem that I didn't have. I need you to please add that the angle at E is 30 degrees. So that angle down there is 30 degrees. Okay, I'm going to ask you to go ahead and pause the tape or pause the video. Sorry, I'm showing my age by saying tape. Go ahead and pause the video and go ahead and give this a try. Figure out what they are. Again, I'm going to encourage you to think about a couple things. DE is a tangent, OD is a radius. So think about how they intersect, and that'll help you find all of the missing things that you have. So go ahead and hit pause. All right, now that we're back, let's see how you did. So I know that this has to be a 90-degree angle, because it is a radius and a tangent intersecting on the circle. So I know it's 90 degrees. That'll make this 60, because it's a 30, 60, 90 triangle. And then I can conclude that AOB is 130, because 90 plus 60 plus 80 plus AOB has to equal 360. All right, I can also conclude some things about some of the arcs. I know this arc would be 130. I know this arc would be 80. This arc would be 60, and this arc would be 90. It looks like I have everything I need to answer all of these questions. So ODE, we found to be 90 degrees. We found DOE to be 60. We found AOB to be 130. We found arc AD to be 90. Arc DC is 60. Arc BC is 80. Arc AB is 130. And the major arc, ABC, would be a combination of them. We'd have to add them up. We'd have to add A to B to B to C, which would be 130 plus 80, or 210 degrees. All right, we're going to move on to the next example. Okay, my hint to you on letter C is to use trigonometry. So give it a shot at using some trig if you need to. Well, actually, it's not even if you need to. You're going to need to. You're going to need to use some trig. So let's go ahead and do that. But again, I'd like you to pause this video and give it a try on your own, remembering that if two chords are equidistant from the center, they're congruent, and they're also being bisected. So think about those different theorems we learned yesterday. So go ahead and hit pause. All right, now that you've tried it, let's go ahead and take a look at what it should be. So I know that this is 3 and this is 3 because they were given to me. We're supposed to find CY. So I also know that AB is 106. So if A to B is 106, then I know this is 53, this is 53. All right, I also know that this is being bisected, which won't be relevant, I guess, at this point, but it's good to note it. So now that I know that, I can go ahead and draw in this central angle. So if you see that central angle, here would be the arc that goes with it. So I know this central angle is a 53-degree angle. Now, I'm trying to find CY. So in other words, I'm trying to find this guy first, because I know that all 4 of these have to be congruent. So I look at that and I say, oh, well, that would be tangent, because I have the opposite and the adjacent to the 53. So I'm going to say tangent of 53 equals opposite over the adjacent. And then if I go ahead and use my calculator and plug that in, I end up getting CY to equal 3.98, or about 4. Now I'm also supposed to say what arc BF equals. We already have that marked, so it's easy to go ahead and transfer that. And our last example for this is actually the easiest one. I don't really have anything to tell you on this one other than just to give it a try. So go ahead and pause the video. All right, now that you've given it a try, we have the circle with center O, and we have OM is equal to 9. And then we're supposed to find the radius. Well, I can draw either one of these as a radius, but I want you to notice that this is a right triangle, and we're trying to find OB. I also know that AB is 24. So AB has been bisected, so I know that this is 12. All right, so I know some of you out there are going to go, oh, when you're done, you're going to realize what this was. We'll call this C. This is actually a 3, 4, 5 triangle. And since it's 3 times 3, 4 times 3, it'll be 5 times 3, so C would be 15, and that will be my radius. Okay, next we're gonna start using a new type of angle. So we've had a central angle, and if you look at number 5, it talks about drawing a central angle. So just a reminder, a central angle has its vertex at the center, and this angle, so if that were 90, equals its arc. So now we're going to have a new type of angle. It's called an inscribed angle. And if you think back to what an inscribed triangle is, this really fits because it just means that the angle is inscribed in the circle. So in other words, the vertex is on the circle. And I was going to have you guys do a little activity and kind of go through and discover this. And you can sure still do that. It's on page 9 if you want to. It's with your calculators. It's using an app called Capri Junior. But hopefully it will make sense as to why this inscribed angle, this angle right here, will not equal the arc. Because it actually, if I would draw the central angle there, like if I draw the central angle, hopefully you can see that that angle would be bigger than the angle we're dealing with. So let's just go back to the central angle, or the inscribed angle. So for the inscribed angle, it's not equal to its arc, it's half its arc. So if we said that this was 90 again, then we would say this angle down here is 45. So an inscribed angle is half the measure of its arc. All right, we're going to go ahead and move on to page 10, number 6. So page 10, number 6 has 8 problems on it because it goes on to page 11. And those 8 problems, I want you to try using these ideas. I'm going to do just 3 of them with you, and I want you to do the rest. So I'm going to do the first one with you. If you notice on the first one, this would be a central angle. So I know its corresponding arc has to equal it, or 146. Then I notice that x is an inscribed angle with the same arc. Well, the inscribed angle doesn't equal the arc, it's half of it. So we simply say, well, 146 divided by 2 is 73. You know what, I said I was going to do 3 of them, but I might only do 2. So I'm going to have you guys go ahead and try the next 3, and I'm going to have you pause the video, try them, and then I'll go through what the answers are. So go ahead and pause the video. All right, I hope that you got x equals 35 here, because this is the inscribed angle to this central angle, so it would be half of its arc. I hope that on this one you notice that if this is the inscribed angle, its arc would be double it. So this angle, this central angle, would equal that arc of 150 degrees. So x equals 150. And on this last one, this is the inscribed angle for this entire arc. So that arc would be 280 degrees. Well, this is the central angle for that same arc. So x would equal 280 degrees. So again, the inscribed angle is half the intercepted arc, so it's also half of the central angle. All right, for this next one, I'm going to go ahead and give you guys a minute to do these 4. So pause the video and go ahead and do them, and then come back and I'll go through them. So go ahead and pause. All right, so on this one, you might have been a little confused, but hopefully you notice that this central angle is actually a semicircle. So this arc has to be 180. It has to agree with that line. Well, this inscribed angle then would be half of that, so it would be 90. All right, on the next one, again, here is a central angle, and that central angle has an arc measure of 86, because the angle measures 86. Do you see how this y is actually an inscribed angle to the same arc? And x is also an inscribed angle to the same arc. So x has to equal y, and they both have to be half of the 86, or 43. Similarly, this next one has the central angle of 150, so its arc is 150. And then I notice that this x also has this arc. One of the ways to figure out what arcs I'm using is to actually extend these chords, and now you can see that that's the arc between it. Just like if I extend the y, this is also still the arc between it. So x and y in this case have to be half of the 150, or 75 degrees. All right, on this next one, there were lots of ways to do it. Hopefully you found a way to be successful. So when I look at this, I see this inscribed angle of 40, and I'm going to go ahead and extend it so I can see the arc that it goes with. So this would be 80. Then I notice that x is a central angle there, so x has to agree with 80. I know that this will be 90 degrees, even though I didn't have to find it just because it's inscribed in a semicircle. It's a right triangle. And then to find y, well, since this is a right triangle, this angle is 40, I know that y has to be 50 in order to have a 180 degree angle measure or interior angle sum. All right, I want you to look on page 12 at number 13. Page 12, number 13, has these 2 new theorems. So we haven't actually discovered all of them, but we've already done them. You just don't realize that you've been doing them. So looking at this, we would have an inscribed angle in a semicircle theorem. This one is saying that if I have a semicircle, so in other words, I have a diameter, so there's the center of the circle, I have a diameter. Anywhere I put a triangle, this will be 90. So it can go there. It can go here. That's still 90. It can go over here. That's still a 90 degree angle. As long as the hypotenuse of any inscribed triangle is a diameter of the circle, then automatically the angle is 90 and it's a right triangle. All right, the next one would be our opposite angles in an inscribed quadrilateral theorem. So again, if I have a circle and I would inscribe a quadrilateral in it, so in other words, just pick any 4 points, there is a relationship between opposite angles. So this angle here and this angle here have a certain relationship, as well as the other pair. And it is not ever that they're congruent unless it is a rectangle or a square. But what I want you to notice is there are 360 degrees in every circle. So this angle right here is an inscribed angle that ends here and would have this arc, arc A. Its opposite angle also has the same endpoints for its arc. It's just the major arc. We're going to call it arc B. So if you notice, A plus B would equal to 360. But also, these are inscribed. Like this angle here is inscribed. This angle here is inscribed. Since they're inscribed, they're half. So I know that the actual angles at A and B have to equal half because they're inscribed. So opposite angles in an inscribed quadrilateral are supplementary. They will always add up to 180. All right, you guys have some work that you can do now. So as soon as you're finished here with the video, would you please go do on page 12. There's two number 14, so I apologize. Would you please do the first number 14? It's 1 through 6. You cannot find on number 5. So on number 5, you cannot find X. So don't worry about finding X. All right, but find everything else for me. And then I will leave a answer key of those with the sub so you can check them as you go if you need to. It can be left at the front or you can just check with the sub. And then go ahead and go on to number 15 and answer yes or no with what you think can be done. All right, we'll see you tomorrow. Have a great day.